This question is asking us to evaluate this integral here. Okay, it looks kind of complicated. You have stuff everywhere, but, I'm going to show you a trick. So first of all, let's start off with something simple. What happens if we integrate x squared? Like what's the whole rule here? The whole rule is if we're integrating something to the, like x to the power of n, well then we divide by n straight away. And we grab x, and we get n plus 1. Okay? And then I guess technically we need a plus c, but because we've got a definite integral, that 1 and the 2 there, we don't need it here. So first of all, this x squared business, all right, what happens here? Well, we divide by 2, and we get x, sorry, I need the plus 1 there, forgot the plus 1. So we have x, 2 plus 1, and then 2 plus 1, and that's equal to x to the power of 3 all divided by 3. And technically you need a plus c, but this is just for demonstration purposes only. But then what happens if you have a plus there? What happens? How does that work? So there's a trick. It's called superposition technically, but it means that whenever there's a plus or a minus, there's no times or divide or to the power of, you can split this up. You can split this up into multiple integrals. So I'm going to write the maths technically about how you do it. And this is actually what you do in your head as well. So this is equal to 1 to 2 for x squared plus 1 to 2 for x. Now when you get fast enough, you don't have to do this. All right? And then finally, I'll just put it down the bottom here because I am running out of space. This is equal to 1 divided by x. Okay, so really, we've done the first bit, haven't we? We've ticked that off. So this guy here, we've completed it. What happens if we try and find the integral from 1 to 2 for x? What is that equal to? Well, that's to the power of 1, and I'm just going to get rid of actually the 1 and 2 there and just make it like this. So that's equal to, now the 1 becomes 1 plus 1, x 1 plus 1, and that is equal to x squared divided by 2, and then technically a plus c. Okay, so let's go to the next step. What happens if I have 1? Well, that's like saying that is x to the power of 0. Okay, because what is anything to the power of 0? Get your calculator out. I know this is a non-calc question, but what is 3 to the power of 0? Put it in your calculator. What is x to the power of 0? Put it in your calculator. The answer will both be 1. You can check if you don't believe me. So in this case, we've got x, 0 plus 1, 0 plus 1 plus c, and that is then equal to x plus c. Finally, we've got this 1 divided by x business, okay? 1 divided by x. Now, anything to the power of negative 1, let's say I have 3 times by x to the minus 1. That is equal to 3 divided by x. Likewise, if I've got 2 to the minus 1, that's equal to a half. Okay, so I can write this out to say that's equal to x to the minus 1. And that makes life so much easier. We just plug it into the same formula that we had before. So that becomes x minus 1 plus 1. Oh, and that kind of like breaks maths a little bit. So apologies, I forgot one step. That this is a special formula we need to use, and that is that if we differentiate, all right, if we differentiate ln, the natural log, that gives us that 1 divided by x. So you can see what was going to happen if I decided to plus 1 and plus 1. I was going to get a divide by 0 error. So that wouldn't have been too great. So that is an error. So Now we've got all the ingredients in here. So anyway, the integral of this guy is just equal to ln of x there. Cool. So now we've got all the pieces of the puzzle. We can write it out as we would. So we write it out to say that it goes from 1 to 2 for x squared plus x plus 1, all of this. And when we get good enough, we should write it as 1 for our sweep here to say x to the 3 on 2 plus x to the 2 on 2 plus x plus ln x. Okay, and that is all the integration that we've done. Now we just need to substitute in the values. So that's what the definite integral is. So we substitute in the values of 2 on the left-hand side. So it becomes 2 to the 3, 2 to the 2, plus 2, plus ln 2, and now minus everything but to the power of, like with the value, sorry, of 1 substituted in there. Okay, there we go. So now let's crunch some numbers here. And what we find is that this is equal to 2 to the power of 2, because it's 2 times 2 times 2 divided by 2. So we can write that as 4. Oh, I made a mistake there. That should be a 3. So that there is by saying 8 on 3 plus 2 plus 2, because 2 squared is 4, 4 divided by 2 is 2, and then plus ln 2 as per usual. And then this is like saying minus 1 divided by 3, right? And then minus 1 divided by 2, minus 1. Now ln of 1, okay, is equal to 0. So that is equal to 0. I'll show you why. So if I've got a log base of x and y, that's like saying the base to the power of y is equal to x. Okay, so if I've got something that's equal to 1, that means that I have to raise it to the power of 0. Okay, so that y value, so that value there, apologies, this value of y has to be equal to 0. So that's why it's equal to 0 in this case. So I'll scratch all of that so the flow of the question works out quite well, and then we'll just go ahead and simplify everything. So 8 divided by 3. Now I'm going to move that minus 1/3 over there, because it just groups the divide by 3's together. And I can say plus 4, grouping them together, plus ln minus 1 there. So there's a bit of a trick here. If they have a common denominator, then you can just draw a line straight across and then subtract them from each other. So for instance, if I have 1/2 plus 2 divided by 2, that's equal to 1 plus 2 divided by 2. All right, so the same sort of principle applies. In this case, I'm going to get that minus 1 and I'm going to subtract the 4 there. So it becomes 3 plus ln 2 minus 1/2. And that's not all equal to 0, but I can scratch that. And so I've got 7 divided by 3 plus 3 minus 1/2. And I really don't have to go this far to simplify it, but I think it's a really good idea to learn how fractions work. So you don't need to do this as part of your as part of the question. It's not worth that many marks, but I think it's useful if you just follow through to understand how fractions operate. So the problem here is that I've got a divide by 3 and a divide by 2, so I need a common denominator. So I can multiply them together to say, hey, if I have a divide by 6 down the bottom, then I can match everything together. So I'm going to grab 7 divided by 3 and I'm going to times it by 1. But this is a special one. This is a 2 divided by 2, right? You still agree with me, right? That that's equal to 7 divided by 3? Let's do the same thing over here. Except this time I'm going to times it by 1, but this is a 6 divided by 6. If you put it in your calculator, what is 3 times by 6 divided by 6? It should be equal to 3. So we're not changing the value at all. And then this one here, I'm going to do the same, but just with the 3. So now I've got a constant 6, okay, with everything. Everything will be divided by 6. And I can get 14, 7 times by 2, plus 18 minus 3. And finally, that will be equal to everything divided by 6. And I'll go 14 minus 3. So 11 plus 18. And finally, that will all be equal to, all divided by 6, 29. Oh, and of course, I have forgotten the final answer here would be that 29 divided by 6, and I still need my ln too. So that's how the fractions work. That's how it all operates. Hopefully that makes sense. If you have any questions, reach out. There's plenty more exam level questions like this on my website, which you can find in the link below.